Hi guys, welcome to my YouTube channel. So this is gonna be my first YouTube channel video, and we're gonna do many lead code problems based on Java, and sometimes we can go with C and Python also. So as this is my first YouTube channel, there gonna be some flaws while I'm explaining or while I'm speaking, so I can request all of you to please ignore them. So let's stop wasting time and get into our first sum. So, as it our first sum, this is gonna be easy to sum. So, according to the question, we're given an integer of nums named nums and an integer variable named target. So, according to the question, we should return indices of the two numbers in the array that whose sum when added they should be equal to the target. For suppose if you see this question, the sum of 2 plus 7 that is given 2, 7, 11, 15. So when we add the 2 and 7, our target equals to 9. So we should return the indices 0 and the 1. So we should now implement the code for this question. So let's dive into the process once. First approach we're going to discuss is brute force approach. If you guys want the optimized solution, you guys can forward the video. You can get the optimized solution at the end of the video. So the given test case in the question is the array nums which points to 2, 7, 11, 11, 15 elements, and the target element given in the first test case is 9. So we should find two elements whose sum whose sum will be equals to the target element 9. So uh, we should return the indices of the elements. So just first find the indices by normal dry test. So which is going to be like, first we'll start with I is equals to 0, which is 2 plus the next element 7. Oh, it's very easy, we got the answer in our first dry test. So um, the answer will be here like 0 comma 1. So let's take one more test case. Nums is equals to some 3 comma 11, 15, 18. So the target element here should be like some 33. So first the brute force approach is like we'll take the first element and we'll add the first element with the other elements step by step until we get the target sum. If we haven't got the target sum, we'll increase the iteration value and we go to the next element and we go to the next element until we get the sum till the last element. So first we'll start with I is equals to 0 and we'll go with j is equals to I plus 1, the next element to the ith element. So the first I is equals to 0 means 3 plus 11, well j is equals to 1, which is 14. So now the target element j is equals to 2, which is 3 plus 15, which is 18. This is not our target element. J is equals to 3. 3 plus 18, which is 21, which is not our target element. So increase the iteration. I is equals to 1 and j will be j I plus 1, which is 2. So the sums will be 11 plus 15, 26. No, not our target element. 11 plus 18, 29. No, sorry guys. Okay, 11 plus 18, 29. This is not our target element. So go to the next I value, next iteration of the ith iteration. I is equals to 2. Then j will be equals to 3. 15 plus 18. So this value will 33. This is our target element. So the target element should be the indices should be j is I is equals to 2 and j is equals to 3, which is 2 comma 3. We got it right. So what we're doing here is like we are taking the first, we are starting with the I is equals to 0 and we are adding it to the next elements, uh, to the ith element, until we get the target element sum, until we get the sum as the target element. If we haven't gotten that ith iteration, then we increase the ith iteration to the next, the I value to the next value, until we reach the end of the array. So let's code this up. Okay guys, let's go with this. So for coding to be done easy here, I divided the question solution into the three steps. So the step one will be the, we need to iterate the I value from the first element to the last element. So it can be done by using a simple for loop. So if you otherwise don't have the for loop syntax, just go to the Chrome or Google and search it, because you need, guys need to know the for loop syntax. So for and I is for 0, this is the initializing phase, and next this is condition checking. We need to exit the loop when we reach the end of the array, and we want to increment single at, at once. So we want to increment one value at one step. So the step will be, we need to increment the j value from I plus 1 to the last element. So for j, for this is condition checking again. So this will be again I'm sorting, and next this will be j plus plus, because one at a time, one at a time. And next we want to check the condition here. The third step, we're going to check the condition if sum is equal to target, because it is the main step. So I'm going to access element at I, and I'm going to access element at j. So I'm going to check if these two are equals to target by using the comparison operator, which is equals to equals to. So what now? Should I need to return, or should I need to check anything else? So there is an important point. You may assume that each input will have exactly one solution. So there is only one solution. But according to question, you have to assume there is only one solution. So if we found a solution, we should just return it. So we should return it at, what does return do? Return does, we will get the value and the function ends there. So we want to return what? We can check it is the return type. We want to return an integer array. So what do we want to return? The indices of the two elements. So I'm creating a array object by using a new keyword, new int, what are we going to create? An array, int array. So int array, what are the elements? I comma j. So then that's it. And there is one more step pending, which is the fallback case. So if we're going to the into the for loop, and if I get an answer, okay, we're getting safely an integer array consisting of indices. But what happens if there is no case where we can find the sum this is equals to target? So the for loop exists, where the for loop here, the for loop exists. So we should add a solver case, which is an null array, because there is no Alice which will be returned. So just return a null array. So new int, that's it. So now I'm gonna run this. So there's an syntax. What case to, what is it? Sorry, this I plus 1. Sorry, that's we need to increase the element into I plus 1. Okay, let's start with this. This is a brute force approach. So not going to be in the top level. We're going to be at some bottom level, because the time complexity will be so high. The challenge is the time complexity of n square, because we are like see guys, this the time complexity for the outer loop will be n, and the for inner loop will be the n. So for one it is n times. So for the n n elements, it is n square. Time complexity is worst case. In the worst case, we'll reach the end of the area, or we may not get the element, which is n times we are running the loop in the loop n times. So which is n into an n square. So the time complexity is n square. So okay, if you guys don't get this, let's gonna make an better video on time complexity when we get some free time. What we should do to get to here? We have to write some optimized solution, guys. We have to write some optimized solution. There are many ways we can use hash maps and everything. So let's do that in the do that. Excuse me. So let's do that in our next video. Because this video has got so much length, so we'll do that in the next video. Otherwise, if you like the video, like, share it and subscribe. That's it. Mm, I think you guys will support me. Thank you very much. Let's meet in the next video.